This will be for the Khan Academy exercise, zeros of polynomials, multiplicity. So first I want to establish what is defined as the zeros. Okay, as you can see here, we have a graph, and right here, these points in pink, where they touch the x-axis, those are the x-intercepts, or the zeros. Okay, the reason they're called the zeros is because they are on the x-axis. And if you were to draw a line on the x-axis, okay, if you were to draw a line on the x-axis, the equation of that line would be y equals 0. All right, and generally speaking, when you have the equation f of x, and you wanted to find the zeros, you set the entire equation equal to 0 and solve for x. So that's why they're called the zeros. All right, so for each of the zeros, I'm just using the same diagram here. For each of the zeros, you're going to create a binomial by doing x minus whatever that 0 is. Okay, this isn't necessarily the number 0, it's whatever number is here. And when the graph touches or bounces off the x-axis, the exponent on that binomial is going to be even. Okay, in other words, 2, 4, 6, and so on. So that's going to be an even exponent on that binomial. And if the 0 crosses right through the x-axis, the exponent on that binomial is going to be odd. In other words, 1, 3, 5, and so on. Okay, and by the way, if there's no exponent on the binomial, it's automatically a 1. All right, so try to remember, if it touches or bounces off the x-axis, that's an even exponent. If it crosses right through the x-axis, that's going to be an odd exponent. All right, and for each binomial, we're going to find each one by doing x minus whatever that 0 is. All right, it says a polynomial p is graphed, and it says what could be the equation of p. And for each answer here, we have a series of binomials multiplied by each other. Okay, some of them have even exponents, like the 2 right here, and some of them have odd exponents. Remember, when there's no exponent, it's automatically to the first power. So this one here has an odd exponent. This one here has an even exponent. We're going to find the correct answer. Okay, remember I said for each binomial, we're going to do x minus whatever the 0 is. All right, so I'm going to start on the right because this one's a little easier. Right here we see the 0. This is the x-axis. We see the 0 right here is at x equals 4. So we're going to do x minus that 0. Since the 0 is 4, we're going to do x minus 4. All right. And right here we have a 1. And the binomial is going to be x minus that 0. So that's going to be x minus 1. And finally, right here, this one is between -1 and -2. So this 0 is going to be x minus -1.5. Okay, and remember that 2 negatives in a row make it positive, so it's actually x plus 1.5. So if you don't have to do this, but if you set each one of these equal to 0, you'll get the 0. Okay, if x minus 4 equals 0, x would be 4, and that's right there. If you set x minus 1 equal to 0, x would be 1. Set this equal to 0, x would be -1.5. All right, so that's how you get the binomials. And now for the exponent part, remember we said when it crosses right through, the exponent is going to be odd. All right, this one crosses right through, the exponent is going to be odd. And this one here, it touches or bounces off, the exponent is going to be even. Now, these two are okay. But in their answer, they do not accept any decimals or fractions. So we need to get rid of it. So if we have x plus 1.5 equal to 0, what can we multiply on both sides of the equal sign to get rid of the 0.5? Well, if we multiply this by 2, we'll have 3. So that would work. All right, so on the left-hand side, I'm going to multiply it by 2. And on the right-hand side, I'm going to multiply it by 2. All right, I'm doing the same thing to both sides of the equal sign. Distributing, 2 times x is 2x. 2 times 1.5 is 3. And 0 times 2 is 0. All right, so instead of x plus 1.5, we're going to have to use 2x plus 3. In either equation, we would get the same value of 0, negative 1.5. So this is really the same as this in terms of the zeros. All right, so if you have a fraction or decimal, just get rid of it by multiplying both sides by that denominator. Or if it's 0.5, just do times 2 on both sides. So I'm going to replace this right here. I'm going to replace this with 2x plus 3. All right, that's the new binomial. And the exponent is still going to be even. All right, so that's it. We have even, odd, and odd. So we want to look for the correct answer. All right, so here are the choices. And remember, when there's no exponent on the binomial, the exponent is automatically a 1. Okay, you don't necessarily have to write the 1 on each one, but just remember that if there's no exponent, it's a 1. So x minus 1 has an odd exponent. In other words, it's going to be 1, 3, 5. All right, so x minus 1 has odd. This one is odd. This one is even. X minus 1 squared. X minus 1 squared is even. Okay, so that's no good. This one's odd. So A or D work. X minus 4 has to be odd. All right, x minus 4, here it's odd. X minus 4 here, the exponent is even. So it's definitely answer A. Let's do a final check. 2x plus 3 has to be even. 2x plus 3, the exponent is even. So it is definitely answer A. Odd, odd, even. Odd, odd, even on the exponents. All right, answer A. All right, I think these are all the same. A polynomial P is graphed. And what could be the equation of P? All right, so same thing as before. For each binomial, we're going to do x minus 0. Okay, whatever the 0 is, we're going to do x minus that number. So right here, we see the 0 is at 1. So that's going to be x minus 1. Right here, the 0 is at negative 1. So that's going to be x minus negative 1. Okay, but 2 negatives in a row make it positive. So it's just x plus 1. Let me rewrite that, x plus 1. And the last one here is in between negative 3 and negative 4. So that's going to be negative 3.5. If we do x minus negative 3.5, that's going to be x plus 3.5. Okay, now let's do the exponents. When it crosses right through, the exponent is odd. When it bounces off or just touches, the exponent is even. And right here, when it bounces off or just touches, the exponent is even. So this one is good. This one is good. This one has a decimal. We have to fix that. All right, if you set x plus 3.5 equal to 0, to get rid of 0.5, we can do times 2 on both sides. All right, times 2 on both sides of the equal sign. Distributing 2 times x, and 2 times 3.5 is positive 7. 0 times 2 is 0. So, in place of x plus 3.5, we're going to use 2x plus 7. All right, so cross that off. And we're going to do 2x plus 7. And the exponent on that root is still even. All right, that part doesn't change. All right, so again, it won't take decimals. If you have 0.5, you have to do times 2, and that will fix it. So we have this one, and this one right here. I'm going to write them out and then look for the answer. All right, so we have the possibilities right here. And just like before, if you want to, you can fill in a 1 where the exponent is missing. Okay, you don't have to. I'm just doing this to show you. Wherever the exponent is missing, it's automatically a 1. All right. So first up, x minus 1, the exponent is odd. X minus 1, odd. X minus 1, odd. X minus 1, even. C is no good. X minus 1, odd. All right. Moving on. X plus 1 has to be even. X plus 1 right here, that's odd. No good. X plus 1 is even. X plus 1 is even. Finally, 2x plus 7 has to be even. We already eliminated A and C. 2x plus 7 is odd right here. The exponent is odd. Has to be even. 2x plus 7, the exponent is even. That one checks out. And it is clearly answer D. Odd, even, even. Odd, even, even on the exponents. Answer D. By the way, if it crosses right at x equals 0, that is going to be x minus 0. Okay, and of course that is just x. And in this particular case, it crosses right through. So it's going to be x with an odd exponent. Okay, just thought I'd mention that. If it's right at 0, x minus 0 is the same as just x.